Hey everyone, so today we'll be looking at Decode ways, which is a DP problem from Neetcode 150 list. So let's give it a try and let's see if we are able to do it. A message containing letters from A to Z can be encoded into numbers using the following mapping. Okay, A is 1, P is 2, and so on up to 26. Got it. So looks like it's capital. To decode an encoded message, all the digits must be grouped then mapped back into letters using the reverse of the mapping above. There may be multiple ways. For example, 1106 can be mapped into AA J, 10 would be J, with the grouping 1 1 10 6, with the 11 10 6. Okay, note that the grouping 1 11 0 6 is invalid because 0 6 cannot be mapped into F since 6 is different from 0 6. Okay, got it. Given a string S containing only digits, return the number of ways to decode it. The test cases are generated so that the answer fits in a 32-bit integer. 12, 2, A, B, and L. Okay, got it. 2 to 6 is 3 BBF. So 0 6 cannot be mapped to anything. So 0 is the key differentiator here. Okay, got it. So I'm thinking that do we need a DP matrix for this as well, or what should we do in that case? So here A to Z is stored in a map, right? In a map. So okay, got it. And how do we identify this? The test cases are generated so that the answer fits in a 32-bit integer. So the first thing that comes to my mind is given the this number, what we need to do is we need to divide it in single characters, and as we did in the case of the as we did it in the case of the substring, we need to traverse, like we need to convert those 1 2 and so on up to the number into their individual characters. But the only issue I find is if it has a 0 anywhere, like if 0 6 is there, in that case we cannot do anything, cannot be mapped to F because of the leading 0. 6 is different from 0 6. Yeah, that is what I am talking about. um so that's the differentiator. May contains leading 0. It may contain leading 0. So the only case that I can think of is, if 0 is there, then we definitely have to consider the number that is um, we have to associate that 0 with the number that is in front of it, and that is for sure. Okay, so I think mm, first of all we need to create a map, I believe, of A to Z, assigning them value 1 to 2. Okay, so how will I do that? So basically I can just do like this. Let alpha bets is equal to A. Do I have to type it all? B. I don't know if this is the right way of doing things. C D E F G, then H I J K L M A B C D E F G H I J K L M N O P Q R oops R S T W R S T U V W X Y Z. So we have this, and then what we do is let alpha map is equal to new map, and for let I is equal for alpha of alpha bets alpha dot set the alpha map, sorry, alpha map dot set count plus plus count is equal to 1. Let okay, so once we do this, then we have our count with us, or okay, So we set the string on 1 and so on up to. So let's see if our alpha is what we are expecting it to be. Alpha map. Oh yeah. So 1, 2, everything is according to what we have done. So yeah, that's the simpler part. But how would you? So let's say if we draw a 26 by 26 matrix, let's say that. Okay. So if that value, if we can construct out of um, something out of it. So yeah, if we can construct something out of it, then for surely um, we can mark it as true and update the count. But the special cases of 0 only. If we have 0 as a leading one, then can we do anything like 0 0 0 1? What about this case? We had a leading 0 but we attached it to something. But just in case, if we have a leading, note that the grouping, what if we have, can I add a case to this? There is no plus sign. Oh yeah, I can add a case to it. So what will happen to this? uh, so if I run this, what will happen to case 4? 0 is expected. And okay, what will happen to this? So okay, so if I have leading 0 anywhere, like if the starting number itself is 0, then I guess we can return it by itself. Okay, I don't have to worry about it. What should we do is, if s of 0 is equal to 0, if this is the case, then we simply return 0. We don't have to do anything else. Okay, in that case, let's keep it at the top because we don't want to waste anything. Okay, yeah. Once that has been taken care of, we can surely do something about this. So for every digit except where we are finding out 0, we should count it as a single. Okay, so how many times do I have to do it? Oh, like it would be, and there can be multiple things that can be created out of it, right? 2 to 6, you can take any combination of that number. And okay, how would you be solving it using dynamic programming? We are already 15 minutes into it, and it doesn't look like we are having much success in solving this question. What if like in dynamic programming um, you have to store the previous value, right? Previous value. What um, how will this help? Let's say a brute force approach. 1 2 2 2 6 is given to us. Okay, so I take 2, select 2, 2, and then I have to select 2 2, then 2 6. It's pretty much similar to, then I have to again go here. It's n square, it's kind of n squared, but how can we do this? Okay, is there a hint or something? Guides, nothing. So let's see what's going on here. Oh, this is a 26 minutes explanation. Cool. The most important point to understand in this problem is that at any given step you are trying to decode a string of number. It can be either single digit decode 1 to a or double digit 25 to y. As long as it is valid decoding, we move ahead to decode the rest of the string. So yeah, either 1 or either 2, right? So okay, the subproblem could be thought of a number of ways decoding a substring. Okay, 326 CBF. Yes, that's one of the way we did a single decode for all the digits 1 to 9. Can be mapped to a I. Also keep in mind. Also keep in my 0 is also a single digit and it doesn't have any mapping by itself. There is no mapping for 32 since double digit mapping are only between 11 and 26. That's the above diagram shows 326 could be decoded in two ways. Recursive approach with memoization. The problem deals with finding number of ways of decoding a string. What helps to crack a problem why there would be why there would be many ways to decode a string. The reason is simple. Since at given point we either decode two digit or single digit, this choice will while decoding can lead to different combinations. Okay. Um so can we pick this up? So we know that we have to do single and double digit. We have to look for single and double digit. how can we do this using memoization? So let's go to this guy. Excuse me. Okay. So we have 3 to 6, right? 3 to 6 we have, and then what we gotta do is we have to either select this 3 one time. So if we select this 3 one time, then it's okay. And then how can we select 3 and then select these two. So I'm not able to think like how we can do it, and how we can recursively call this 3 and 2 and 6. Okay. Let's see what's going on. So if single digit decoding was allowed, if there was just single digit decoded, then there is only one choice to make at each step. Hence there has to be done only one way of decoding. If no double digit decoding is allowed, if only double digit decoding is allowed, when two digit decoded is allowed, after decoding 3 we have 2. So what we can do is single digit. First we can do a single digit reversal. For let I is equal to 0 and let's take let n is equal to s dot, where the hell is it, s dot length, and then what we need to do is I is less than n, I plus plus. What we have to do is we have to check if map so just in case if there is a 0 in there, how will you manage it? How will you manage it? Like okay, thus at any given time for a string we enter a recursion after successfully decoding 2 digits to a single character, or a single digit to a character, this leads to multiple path. So for entire digit, what we do is 3 to 6 we consider, and then 3 2 cannot go, then 3 2. In the following diagram, we can see how the path have to deal. Okay, so for recursion DFS, if DFS, we need to work on S, right? We need to work on S, but in the following diagram, we can see how the path have to deal with similar subproblems. Let me reset this. Okay, or overlapping subproblem means we can reuse the answer. Thus, we do memoization to solve the problem. 23, 26, 2, 3, 2, and 6, 3, 2, 3, and 26. 2, 3, 32 is not there. Okay, you might have noticed that there are 4 successful paths, hence way to decode 2326. What we also need to pay attention to is the rework that is shown. Enter the recursion with the given string that starts with index 0. For the terminating case of the recursion, we check for the end of the string. If we have reached the end of the string, we return 1. Okay, DFS. 0, start with 0. Every time we enter recursion, it's substring. It's for a substring of the original string. For example, for any recursion, if the first character is 0, then terminate that path by returning 0. Thus, this path won't contribute to the number of ways. Memoization helps to reduce the complexity, which would otherwise be exponential. We check the dictionary memo to check if the result for the substring already exists. If the result is already in memo, we return the result, otherwise the number of ways. Okay, this was useless, we don't need this. Okay, so hash map, then recursive 0. If memo contains index, memo dot get index. If you reach the end of the string length, return 1. If the string starts with 0, it cannot be decoded, return 0. if index equal to string length -1, then also return 1. Any answer recursive with memo index +1, and if integer parse string index +2 is less than equal to 26, then answer index +2 so put uh, put index answer. Okay, so I did not get this recursive with memo index. So all that matters is that we okay. I think I got this, how they are working here. So return DFS of 0. We have to start with 0. Okay, yep. So function DFS start so basically what we need to do is, if let's call it index, if index is not equal to 0, if index is not equal to 0, then what? If index reaches is greater than equal to, I guess we have to type greater than equal to s dot length, then return 1. If s of index equal to 0, then return 0. We don't want to do anything. If index is equal to s dot length -1, then also return 0. Okay, and once we have done that, what we need to do is let answer, let count is equal to dfs index plus 1. Okay, now here we check if so. How do we check it? Index s dot sub string of index comma index plus 2 is less than equal to 26. So first of all, let double digit is equal to, let's take that double digit is equal to number double digit, convert that, and then check the double digit but I'm afraid um, if that goes out of bound. Does it go out of bound? I'm not sure. If the double digit is less than, then count plus equals to dfs index plus 2, right? Because we are taking that 2 digit, and then finally we return answer, right? So if this works for these small, not answer but count. I guess why is it coming as 1? Oh, sorry, my bad. Okay, this is accepted, but if we do this, then it should probably time out because we are not using, and this would be 2 raised to n. Yeah, it did time out. So let cache is equal to new map, and then what we need to do is to store map, sorry, cache dot set for that index, right? Index count, and if I have that index map, sorry, not map, cache dot has that index, then return map dot get index, right? If Why am I writing map? Okay, yeah, it did pass. However, of an iterative approach. I guess we'll do it tomorrow. It's already too late. Okay, otherwise let's do it. Okay, let's push ourselves a bit more and let's try to at least read this, and then we can come back tomorrow and give it a try. The iterative approach might be a little bit less intuitive. Let's try to understand it. We use an array for TP to store the result for subproblems. A cell with a cell with index I of the TP array is used to store the number of decoded ways of substring S from index 0 to index I minus 1. We initialize the starting two indices of TP array. It's similar to relay race where the first runner is given a baton to be passed to the subsequent runner. The first two indices of the TP array holds a baton as we iterate the TP array from left to right with this baton, which signifies the number of ways of decoding is passed to the next index, or depending on whether the decode is possible. DP of I can get the baton from two other previous indices, either I minus 1 or I minus 2. Two previous indices are involved since both single and two digits are possible. Unlike the relay race, we don't get only one baton in the end. The baton add up as we pass on. If someone has one baton, they can provide a copy of it to everyone who comes to them with a success, thus leading to number of ways reaching the end. So we have TP array, we add 1, initialize the TP array 1 1, the TP array. So find the number of ways of decoding the substring 32, what we would store in dp of I. Single digit decode 2 is a valid single digit decode, thus whatever is in dp I minus 1 we add to dp of I. This means if there are n ways of reaching dpi n ways of reaching dpi minus 1, now these n ways also lead to dp of I. Double digit 32 is not valid decode, thus the decode path that leads to dp of I minus 2 does not lead to dp of I. This is an example of how the baton dp of I minus 2 is not passed on to dp of I. dp of I, number of ways of decoding substring I. So we might say dp of I is equal to dp of I minus 1 plus I minus 2, which is not always true for this decode ways problem as shown in the above diagram. Only when the decode is possible we add the result to the previous indices. Thus in this race we don't just pass the baton is passed to the next indices or not, depending on possibility of the decode. Algorithm: if the string s is empty or null, we return the 0. Initialize dp array to 1 to provide the baton to be passed. If the first character of the string is 0, then no decode is possible, hence initialize dp1 to 0. Otherwise the first character is valid to pass on to the baton dp1. Iterate the dp array string at index 2. The index Iterate the dp array starting at index 2. The index I of dp is the ith character of the string. the index I of dp is the ith character of the string s, that is character at index I minus 1. We check if single digit is possible. This just means the character at index I minus 1 is non-zero. Since we do not have a decoding for 0, if the valid single digit decoding is possible, then we add dp of I minus 1 to dp of I, since all the way up to I minus 1th character, now leading up to the ith character 2. We check if the 2-digit decode is possible. This means the substring s of I minus 2 I minus 1 is between 2 to 26. If the valid 2-digit decoding is possible, then we add dp I minus 1 to 2. Once we reach the end of the dp array, we could have ways to decode a string of size unless the string is 0. 0 doesn't have a single digit. So 2 char of I minus 1 is not equal to 0. Check if then dp of I is equal to I minus 1. Check if successful 2-digit substring I minus 2 to I pretty neat. Got it. Okay, lot of interesting comments in the comment section, but let's go here and check this out. So once we have submitted this guy, yeah, we can get rid of this. Let's say let call dp is equal to new array. Let's call let n is equal to s dot length and n plus 1. So dp of 0 is equal to 1 and dp of 1 is equal to, if s of 0 is equal to 0, then we keep 0 or else 1. That's that. And for let I, what the hell am I typing? I is less than n I plus plus, then what do we do? And finally we have to return dp of n, so 2 for all single digits. For all single digits we have to make sure dp of I is equal to dp of I minus 1, and if let dp of, so double digit is equal to s dot substring of I minus 2 to I plus 1 I, then double digit is equal to number double digit, and once we are done with this, okay, let me reset this again. Once we are done with this, if double digit is greater than equal to 10 and double digit is less than equal to 26, then we can add dp of I plus equals to dp of I minus 2, and okay, but I'm okay, yeah, if it is not 0, if s of I minus 1 is not equal to 0, then we have to do this. Sorry, n plus 1. Why is this feeling here? Why is it coming nan? Console dot log dp, and let's try to run it. Let's fill it with 0, right? Okay, got it. So, okay, probably this is a bit tricky to come up with. Um, I guess we need to go through this once or twice again to really understand what's going on. So that's it for today. We have I was supposed to be completing all this, but I managed to cover uh, like 6 questions today. Um, so yeah, let's try to wrap up these other questions tomorrow, hopefully, and we can see 2D dynamic programming to probably tomorrow or day after tomorrow. Okay, guys, that's it for today. Good night. See you